In the age of AI and data, the economist who understands data tools will shape decisions, not just study them. Welcome to the Data Fluent Economist. Today, economics is no longer limited to theory, graphs, and classroom assignments. Modern economists are expected to work with real-world datasets, dashboards, forecasting tools, and business intelligence platforms. This presentation provides a practical roadmap to combine economics with modern data analytics skills like Excel, SQL, Python, Tableau, and R. The goal is not to become a software engineer. The goal is to become an economist who can confidently work with data, generate insights, and stand out in a competitive job market. Traditional economics teaches theory, econometrics, and policy thinking. But modern employers increasingly expect economists to also understand data tools. The good news is this: you do not need to become a hardcore coder or AI engineer. You only need practical fluency. When you combine strong economics with practical data skills, you become valuable across multiple sectors: policy think tanks, RBI, consulting firms, analytics companies, corporate strategy teams, and even PhD programs. A student who understands both economics and data can move from simply analyzing ideas to solving real-world problems. That combination is extremely powerful. Think of these tools as different instruments in a professional toolkit. Excel is your foundation. SQL helps you extract and manage massive databases. Python enables automation, forecasting, and analytics. Tableau helps transform data into visual stories and dashboards. And R remains highly respected in research and econometrics. The important point is this: you do not need mastery of everything immediately. Different careers require different combinations of tools. The smartest strategy is to learn tools in the right sequence and with a clear purpose. That saves time, avoids overwhelm, and builds employable skills faster. Excel is still the most important starting point for economists. Why? Because almost every internship, research project, survey dataset, and office workflow begins with spreadsheets. Excel gives immediate productivity. You can clean messy data, summarize information using pivot tables, create charts, and perform quick analysis within days of learning. For MA economics students, Excel becomes useful almost immediately. Assignments, survey work, budget analysis, and research support all become easier. The key skills to master are formulas, lookup functions, pivot tables, data cleaning, and simple dashboards. Never underestimate Excel. Even in top organizations, strong Excel users are highly valued. SQL is the language used to communicate with databases. Modern organizations store millions of rows of information: banking records, retail transactions, NSSO datasets, economic surveys, and customer analytics. SQL helps you filter, organize, and extract exactly the data you need. For beginner analytics jobs, SQL is often more important than advanced programming. The core concepts are surprisingly manageable: select, where, group by, join, and order by. Once you learn SQL, you can work with large datasets confidently, something that immediately separates you from average applicants. SQL is one of the highest ROI skills in analytics today. Python is extremely powerful, but many students learn it the wrong way. You do not need to learn software development. Instead, focus only on the parts useful for economists: data cleaning, visualization, automation, forecasting, and basic econometrics. Libraries like Pandas, Matplotlib, and stats models are enough to become productive. The advantage of Python is future-proofing. It opens doors to analytics, AI-assisted research, automation, and advanced economic analysis. And the best part? Within 1 to 2 months of focused practice, most students can become functionally useful in Python. The key is consistency and project-based learning. R and Tableau serve different purposes. R is highly respected in academia and econometric research. Many researchers and universities still rely heavily on it for statistical modeling. Tableau, on the other hand, is about communication and storytelling through data. A dashboard can explain complex economic patterns far more effectively than raw tables. Here is the strategic approach. Learn Excel, SQL, and Python first, then specialize based on your career goals. If you move toward research and academia, learn R deeply. If you aim for analytics, consulting, or business intelligence, focus on Tableau or Power BI. Specialization should come after building strong foundations. Different careers require different combinations of skills. If your target is RBI, policy research, or DSE coursework, Excel and R may be sufficient initially. If you want research assistantships or academic projects, R and Python become valuable. For corporate economics or analytics roles, SQL and Python are extremely important. And for dashboard-oriented analytics jobs, SQL, Python, and Tableau create a very strong profile. This is important because many students waste time learning random tools without a clear destination. Your learning path should match your career objective. Clarity saves years of confusion. This roadmap works best when executed in focused phases. In the first month, focus on Excel, SQL basics, and refreshing statistics concepts. By the end of this phase, you should comfortably clean datasets, create pivot tables, and write basic SQL queries. In the second month, start Python basics and dashboard projects. Your output should include 1 dashboard, 1 analytics notebook, and 1 small economics data project. Remember, employers care less about certificates and more about visible output. Projects demonstrate capability. Even small projects can significantly improve your profile. You do not need expensive boot camps to succeed. A zero-budget path is absolutely possible today. YouTube, Kaggle, Great Learning, Free Code Camp, Tableau Public, and open resources provide tremendous value. However, if you prefer structured learning and recognized certification, the Google Data Analytics Certificate is one of the strongest paid options. It provides beginner-friendly structure and strong branding. But remember, no course alone guarantees success. The real differentiator is consistent practice and portfolio building. A disciplined learner using free resources can outperform someone who only collects expensive certificates. This slide may be the most important idea in the entire presentation. Avoid passive learning. Do not spend months endlessly watching courses without building anything. Real analysts learn through an output loop. Learn a small concept, practice immediately, build a mini project, and upload it to a portfolio. That cycle creates real skill. Even a simple dashboard or small economics analysis project builds confidence and credibility. Employers trust demonstrated ability more than theoretical knowledge. Progress comes from creation, not consumption. The future belongs to people who can combine domain knowledge with the ability to work intelligently with data. The final goal is not merely learning software. The goal is becoming a data-fluent economist, someone who understands economics deeply and can also analyze, clean, visualize, and communicate data effectively. That combination is still rare. And because it is rare, it is highly valuable. A student who combines economics with SQL, Excel, Python, and visualization skills immediately stands apart from standard applicants. The opportunity is enormous for those willing to build practical capability consistently. Thank you, and all the best on your journey toward becoming a modern, future-ready economist.